from high level. The architecture itself is just going to be AppSync API with lots of DB tables and Lambda functions. So if you move a level up, we also have multiple AWS accounts, which is a good security practice. Helps you limit the blast radius of any security breach you may experience. And it also gives you consolidated billing and billing report across different accounts. So I use AWS Organizations for managing the different accounts. And we had the 4 different independent organization units for dev, staging, production, as well as a separate org unit for manage the shared resources. For example, there's a shared users account for single sign-on, a shared account for collecting all the audit information, such as CloudTrail logs and things like that. And then at the organization root, I have a couple of service control policies, for example, to deny access to all services outside of EU West 1, because that's the only region we are using, and also it denies access to any EC2 actions anywhere, because we shouldn't have any EC2 servers running in our entire stack. And again, this was all done by basically one person working part-time for a few weeks, and it's only possible because I could stand on the shoulders of giants. Really, most of the hard work was done by AWS and the different services that they offer, and I can use tools like the Serverless framework to help me manage and deploy my application. So my name is Yan. I've been working with AWS for a very long time now. Started working with AWS back in 2009. And since, I guess, 2018, I've been an AWS Service Hero. And last couple of years, I've mostly focused on serverless technologies. 2016, I worked for another social network where I migrated them to serverless as well. So this is, you can read about that at this link here. So nowadays, spend half my time working with Lumigo as a developer advocate. And Lumigo is a troubleshooting platform for serverless applications that makes it a lot easier for you to debug your application compared to using some of the built-in tools you have within AWS, like X-Ray, CloudWatch, and so on. So the other half of my time, I spend working as an independent consultant. So I work with companies from all around the world, really, and help them get go faster for less by successfully adopting serverless technologies. In my spare time, I've written a few books for Manning, published a few video courses myself, and I run the weekly podcast called the Real World Serverless, which Ken is going to be on pretty soon, I think in a couple of weeks' time. So looking forward to that. So if you are not familiar with GraphQL, it's just a quick introduction. So in terms of GraphQL, basically it has a couple of components to it. There's the schema language that lets you define the data types and operations that you want to support, including the ability to query, queries for fetching data and mutations for updating data. There's also subscriptions as well, which I have included here. And then your client application is going to send a query or mutation to a GraphQL server, which is then going to interpret the query based on the schema you've got. It's going to validate it, and then it's going to then pass those requests and then handle individual bits of the request with different resolvers that, in this case, can fetch data from different data sources you have within your AWS environment and then stitch them together in the format that the client has asked for. So if you've got like a user object, the client may only ask for the ID and first name and last name, even though there are other things you can that's available on that role in, say, DynamoDB. So, so you can think of it as your sort of backend for front end, except you don't have to write any sort of bespoke endpoints every time a client wants another piece of data or they want them in a different shape. And AppSync is basically a managed GraphQL server that lets you map those requests and mutation operations, as well as any data types you've got, to different data sources you have in AWS. And it supports DynamoDB, Lambda, Aurora Serverless, and Elasticsearch, as well as any raw HTTP endpoints you have. It supports all of the, all 5 of them out of the box. So as example, so as user who's logged in, I want to fetch my profile, and in my query, I'm able to fetch everything you need in one query, in one API request. including ID, first name, last name, gender, and what sport I'm interested in. So these are then mapped to a profile table in DynamoDB. So AppSync is going to fetch my profile using my authenticated user ID that Cognito has provided. So we don't take the ID as part of the request. It's always based on your identity that Cognito has resolved. But then the list of the profiles, the list of sports I have in my profile, they only contain the ID for the sports. Because we want to be able to change the name for the sports and image URL for the sports and so on without having to update everyone's profile. So we don't bake them into the profiles objects. So what we're going to do is we're going to have to take the ID from the row you get back from DynamoDB for that profile, and then have to expand them into full objects and fetch the sports name, image URL, and things like that for every sport that I'm interested in. So within GraphQL, that's called a nested resolver. In this case, AppSync can then, for each of the sports in that array, it's going to then fetch the information from the sports table in DynamoDB. So we know if we're good there, there's no need for the client to send two separate requests. You can save us some additional round trips so they can get everything in just one request. And then for the activities I have arranged, since I can have many of these activities, so I don't want to fetch all of them when I fetch my profile. But what I can do is I can fetch the first page of the activities I've got for the next lot of activities I've arranged. So most likely that's all I'm going to be doing until someone opens the app, look at their activities and start scrolling. Then you can start to fetch the next page and the next page and so on. So AppSync can run a query against the activities table again, or where the data is stored, along with my user ID as the hash key. So the time and the timestamp for the activity as well as a range key. So that way we can really easily get pages of activities in descending order, because that's what I'm mostly likely going to be looking at for the next set of activities in the future. Because other people may want to join my, say, basketball match next week, I also want to fetch any requests that I've received so far as well. Again, we only store the user ID in those requests. And to display the actual request in the UI, we need to show, maybe it's Brian and Ken that need to show your images and your name and other things like that. So we need to expand those IDs into full profile objects, which again have then go back to the profiles table. So we've got another nested resolver to do that. So as you can see, with GraphQL, this is all very flexible. The client can basically ask for any information they need, but you can probably also sense the danger here as well, that the client can just end up asking for way more information than they actually need. And you can have very deeply nested queries that can start to impact performance and your costs as well. So luckily, some of the things you could do here to mitigate that risk is to enable caching in in AppSync, which lets you enable caching on the entire request, or in this case, on specific resolvers. And you can also adjust the cache TTL for each resolver as well. So for the sports, they are pretty static. So I'll have a really long cache TTL on those. But for user profiles, no, I have a shorter TTL, but it may still be like an hour, something like that. And also to sort of prevent further nesting that you may want to, that the client might do. I can also to prevent the leaking any sort of personal information like date of birth and things like that. I've got two separate types for your profile, which only you can fetch using your, it's going to be using your user ID from Cognito, as well as, and there's also a public profile, which other people will be able to see and then load for you when they see you in the app somewhere. And that public profile has got a much flatter structure that you can't really do much more nesting on top of that. And also it doesn't allow us to return information that should be, that's more sensitive, like date of birth and things like that, which can also be used as a security question for a lot of things. So that one query returns all the information I need to display for my profile. And when you see other people's profile, you're looking at the data that's available through the public profile type. So you won't have some information that is available on your personal profile. And the AppSync itself is very scalable. The GraphQL subscription itself can support millions of connected clients at the same time. And your AppSync API is also deployed to multiple availability zones out of the box, which is going to give you really good baseline in terms of resilience and redundancy. And you only pay for what you use at $4 per million operations. So that's about the same as API Gateway REST APIs, which is $3.50. But keep in mind that one AppSync request can handle a lot more data back that you may have to make multiple round trips to API Gateway in order to fetch the profile and then the list of sports and then the list of activities and so on and so forth. You can bundle them all in one query against API against AppSync. So it's not really fair comparison. It's more apples and oranges. All right, as I mentioned earlier, there's a built-in caching support, which charges you extra. Essentially, it's very similar to API Gateway. You're essentially paying for uptime for a memcached node, which you don't have to manage yourself, which is pretty nice. It's got the built-in monitoring support through CloudWatch and the CloudWatch logs. And similar to API Gateway, you get high-level metrics like number of API requests, error count, and latency, and all that, which is great. Unfortunately, also like API Gateway by default, all of these are aggregated for the whole API. So it's really difficult for you to tell which resolver is causing a problem. So a single query can have different resolvers that fetch the profile, that fetch the sports, that fetch something else. You can't tell which one was slow. You can only tell that something the hit API got a slow response. So what you need to do is you need to enable logging. And if you enable the resolver logging and turn it to all, then you're going to get a lot of information about what's going on. You can actually trace through when the AppSync receives the request, how long it took for each of the resolvers and the input and output for the different steps as well. So this allows you to really narrow it down to specific requests and resolvers that took a long time. You can also look at the logs and to figure out what was the request and what was the response, all of that, which is great, but it does have a pretty big cost if you leave it running full, all the time, because it's going to write a lot of stuff to CloudWatch logs. And for performance issues, it's also possible for you to enable X-ray tracing. So, and it really kind of shines the light on what's happening under the hood. And it's not I guess, unusual for a single AppSync request to involve lots of different DynamDB requests. And you can see in X-ray trace which one took how long, and you can figure out which one was the culprit that caused your request to took longer than it should. It shows you a high-level service map with X-ray. Within X-ray, you can get like a high-level view of the services that your AppSync API is talking to and the overall, I guess, performance and health. But it's very high-level. I don't find it to be particularly useful. That said, the big thing is that there's no servers I've got to manage, which is pretty amazing. But you might have also noticed, as I was talking earlier, that I've got lots of different tables. And in fact, I've got, I think at this point, 14 or 15 tables in DynamDB. And if you've been following along with what's happening in the discussion around DynamDB, you probably been heard about this single table design where you can put a lot of different entities within the same table, and then you use global secondary index and for other things like that to access them separately. And you might be wondering why I didn't condense all these tables I've got into a single table. I do use the modeling techniques people sort of use the single table designs with. I do put some entities into the same table, tend to be entities that always need to be queried together and are keyed against the same hash key. But other than that, I really don't see any reason why I should force myself to put everything into one table. It's just, in most cases, impractical. And I'm also quite careful with using global secondary indices. You have too many of them. For starters,
we're losing the audio there, Jan.
Can you still hear me?
Yeah, your audio cut out there for the last 30 seconds or so.
Okay, says my internet connection is unstable. Don't do it. So
one thing we found, maybe as much as we love seeing you, maybe cut your video.
yes, I can do that. Let me just do that now. How's my audio now?
Very good, thank you. The
Okay.
last thing we heard you saying was that you didn't feel the need to force everything to be in a single table. We
Right.
sort of lost you after that.
Okay. So yeah, I don't see why I need to force myself into putting everything into one table, because in most cases it's just not practical. And I'm also like quite careful in terms of using global secondary indices, because there are some serious problems you can run into when you've got too many of them. One of them was CloudFormation can only update one global secondary index at a time. So if you ever need to add the 2 GSIs in one update, then you're kind of stuck. It's just not going to happen. CloudFormation is going to fail when you try to deploy. If you need to rename a GSI, which really in terms of CloudFormation means delete and then insert again, 2 updates, not going to happen. So you have to be quite careful. You have to sort of manage your commits and what you push through your CI pipelines quite careful, so that you only update one GSI at a time, which is just so easy to mess it up. And it's just problems that you don't want to be dealing with when you try to push things out quickly into production. And also when you're building something new, you just haven't figured out all of your access patterns yet. And whenever you change your mind, those changes are going to be much more difficult if you're dealing with lots of GSIs, especially since you can't deploy 2 of them in one go. So, do you really want to deal with that? I mean, personally, I don't. And also, often when I need to read a couple of related items from different tables in one request, which is one of the reasons why you may want to use a single table design, because it lets you do a single query rather than, say, 4 separate get items. Well, AppSync kind of takes care of that complexity for me already, and it just stitches them together nicely. So I don't kind of need that anymore. And also, if I'm using single table design with AppSync, it also means that I'm end up having to write a lot more custom VTL code than I would like to, than I have to otherwise. And I don't know anyone who likes writing VTL code. It's just not the nicest thing to work with here. But you may also say, well, what about the potential cost savings? One of the arguments for using single table design is that you can use one query to fetch multiple items. And because of the way the read units are calculated are based on item size, means that you can potentially save a lot of read units with queries rather than, say, okay, so imagine you do one query, you fetch 4 items for 4 different entities. That's going to count as 1 read unit probably, if it fits within the 4K item size. Versus if you have 4 tables, 4 different tables, 4 different entities, then that's 4 separate get item requests, which is going to count as 4 read units. So you're making quite a big saving there in terms of the read units. In practice, how much difference that actually makes, I'm not sure. I haven't seen any, I guess, in the real world anecdotes around cost savings on DynamDB when you move from multi-table to single table design yet. But you know what? Even more importantly, a sensible caching strategy is going to save you far more in terms of cost than single table design is ever going to save you, because you cut out most of the requests to DynamDB before they even happen. I mean, we've been running for a month now in production, and I've got a 99% cache hit rate on average throughout the day. So yeah, been live for a month, up to about 150 to 200,000 API requests per day. And the last month, and a lot of that requests are pretty intensive in terms of how much data they load from DynamDB, because again, one query, the AppSync, can mean 15 different DynamDB operations. And our AWS bill last month for DynamDB was $4. I mean, sure, at super high scale, I mean, if you are talking about AWS.com, so Amazon.com, then those small cost savings from a single table design is going to be pretty significant. But for this app, we don't need to optimize for the best cost efficiency, and the multi-table design is more than sufficient for our needs, at least for the foreseeable future. And the thing with a single table design is that it's also much more complex and requires a lot more, I guess, more thorough understanding of how DynamDB works under the hood, especially in terms of global secondary indices and using sparse indexes and things like that. So I don't remember who actually said this, but I really love this quote that you should design your systems as if it's going to be run by idiots, because one day it will be. And in most cases, that idiot is going to be yourself in 3 months' time, who can't remember exactly why you did something today. So as much as I enjoy single table design techniques, and I do use them sparingly, I just don't think it makes any practical sense for me to arbitrarily restrict myself to using one table for everything. So that's kind of, I guess, single table designs and why I don't use it. But in terms of authentication, as I mentioned earlier, we use Cognito user pool, and I have set up a identity federation so that users can also sign in using Facebook and Apple as well. And on the client side, we're using the Amplify.js library to integrate with Cognito, which really makes things quite simple as far as authentication is concerned. However, I didn't use the Amplify CLI to create and configure the Cognito user pools. I configured them with raw CloudFormation in the Serverless framework. And also worth pointing out that Amplify is not just one thing, it's 3 different things. There's the client-side library, which we use. There's the Amplify CLI, which we don't. And then there's also the Amplify service, which allows you to host the single-page applications, similar to like Netlify and other things like that, which we also do use for the CMS. So why not Amplify CLI? Well, partly because I already know how to do it with CloudFormation. And if anything, when I think about, even though I think Amplify CLI is great for really quickly bootstrapping a new app, especially for a team that just doesn't have strong experiences with AWS and Cognito, it helps you get something going quickly and give you some good defaults. But I've also heard that it doesn't cope so well with changes. And a few people have told me that they've had to delete the entire stack when it got stuck, and they can't deploy any more changes. And again, not something that I'm willing to deal with on the client project. And Amplify can also provision and configure DB tables and AppSync APIs for you as well. But I don't agree with a lot of the decisions that it makes. For example, how it defaults to using DB scans for list operations. And in this particular case, DB schema and the access patterns are really important. I mean, they've got potentially huge scalability and cost implications. So I want to have a tighter controls around that and need to understand my access patterns really, really intimately. And ultimately, I guess I just think Amplify CLI hides a bit too much important details from you, details that you really should be familiar with if you're going to be running something in production. And the fact that you can't drop down to the CloudFormation level when I need to is also going to restrict me when I need to make certain kind of changes, which requires a bit more delicate touch. Oh yeah, and don't forget, we also build the CMS as well, which also uses the Amplify.js library to authenticate users against the Cognito user pool. And as an admin for the app, which is basically going to be the founders, they can onboard new universities and configure the sort of list of sports you can select in the app. But when you onboard a new university, we're also going to send an invite to the admin staff at the university as well. And then we're going to generate a temporary password for them. And we're going to register the user in the user pool, which is all done by a Lambda function behind it, behind the CMS AppSync. So the user is then able to log into the CMS. They'll be asked to update their password, which is all done by Cognito. And then with the CMS user we created for them, we also be adding the user to the university group to identify them as a university admin. And then we also use a custom attribute to tell us later on when they log in that which university that they are the admin for, which is then passed along to us, to the backend functions by Cognito, to AppSync by Cognito when the user actually talks to the CMS AppSync. So at any point, at no point do we pass the university ID to the backend to say, hey, trust me, I'm the admin for this university. Just let me have access to the data. It's always based on your identity, which is really important. So principle to follow here. And then when you are the admin for a university, you've got different options in the CMS compared to the founders, which limits you to just acting on your university's data. And the nice thing with AppSync is that when it comes to implementing group-based authentication and using cognito groups, if you're an admin, you'll be able to get university details by name, and you can add this, the sports you have in the app, and we can use this very simple what do you call it, attributes or decorator on the operation to say this can only be done by users in the admin group. But if you are the university admin, then you can only touch data that are about your university. And again, we can add this decorator to say this operation can only be done by people in the university user group in the cognito. And if you don't specify any specific options, then any logged in users can do these things, like getting an upload URL for image assets and things like that. So as we move a bit closer to the code, I use the serverless framework to help me package and deploy the app. It's mature, it's got a great community around it. It's also very extensible through a whole host of plugins from the community. And we're gonna see two of them in a minute, which I've used really extensively on this project. I was very familiar with it already. It's been my go-to option for many years now, and I'm really proficient with using the serverless framework. In this case, I've got one repo for the whole backend. Everything is configured in one serverless YAML and deployed as one CloudFormation stack. So resource reference and all that was pretty straightforward. But as the project grew and to deploy, I just had one command I need to run to serverless deploy. That's it. But to make it possible for me to configure AppSync resolvers with the server framework, that this plugin called the Serverless AppSync plugin, which makes things super easy. So we got two AppSync APIs, as I mentioned, one for the mobile app and one for the CMS. So I broke this out into their own files to keep the YAML file itself a bit more manageable. Each of those files is going to look like something like this, where you've got the cognito user pool that's configured and hooked it up. And I configure logging. So for production, we don't want to log everything because it's going to generate too much logs in CloudWatch and has got a pretty big cost associated with that. So what I've done is instead, I've got a cron job that enables detailed resolver logging for like a couple of minutes, an hour, and then turn it back off again, so that we got some logs from those resolver logs, but we don't keep it on 24/7. And then I'll configure my resolvers and data sources in the same file. And for most of these resolvers, it's going straight from AppSync to DynamDB. So the request and response template is going to be written in the VTO, which is the templating language that API Gateway uses as well. So I'm kind of familiar with it. The good news is that for most of my use cases, I just go to the AppSync reference page for DynamDB, copy the one I need, and then paste it in and change the name of the DynamDB attributes to what makes sense for my table, and that's it. I don't really have to write custom VTLs for if loops, if else, and for loops and things like that. But as the project grew, I really quickly hit the 200 resources limit. Since I have also tried to follow best security principles, the principle of least privilege, and I have IAM role for every Lambda function. So it really didn't take me very long to get up to 200 resources for CloudFormation. So that's where the second plugin came in, the serverless plugin split stacks, which allows you to split your one stack into multiple stacks by splitting resources into nested stacks. The great thing here is that it lets you control the splitting logic yourself, which you can write a custom JavaScript module, which is very handy. So the nice thing with this approach is that you don't need to refactor the project. The plugin just moves the things around and put them into nested stacks while it still preserves all the existing references you have between different resources. So don't need to refactor the entire application to make it work. But you still got to be quite careful not to create circular references. And you also have to be mindful of limits, such as the fact that CloudFormation stack cannot have more than 60 parameters, which means that you need to really minimize the number of references across nested stacks, which are going to be passed in through CloudFormation parameters. And there's also a limit on 60 CloudFormation outputs per stack as well. So again, things to keep in mind there. And if you look at the resource graph for how an AppSync resolver is sort of constructed together, there are quite a few different resources in play. You've got the data source, could be DB, could be Lambda function, whatnot. You've got the IAM role, you've got the actual Lambda function or the DB table, etc., etc. And I have to find clever ways to sort of group these things together so that I don't bump into any of those limits. So after, and also to not have circular references. So after several iterations on the how to split the project to just not have like a ceiling that I'm going to run into when I hit 400 resources and then 500 resources and so on, I found an approach that actually is infinitely scalable as I grow the project further more and more. So at the time of writing, we've got over 200 AppSync resolvers across the 2 APIs. And we also have more than 600 CloudFormation resources in total as part of this project. And the best way I've found to split this is to start at the data source and then traverse your graph, your resource graph, and you find and you group the resolvers and other resources that it depends on, or the data source, or that depends on the data source. And you make sure that they stay together in the same stack, and that lets you minimize the number of references across different nested stacks. But for things that hold user data like DB tables, I'll still keep those in the root stack, and I will have the deletion policy set to retain. And also, you need to have them in the root stack because they're shared across different the 2 GraphQL APIs as well as other Lambda functions that are outside of the GraphQL API. So once I've done this kind of grouping of the resources by data source, I can then group them again into, say, 10 nested stacks, and I will hash the logical ID of the data source and use the hash to work out which nested stack a group of resources belong to, so they don't move between different stacks as I add more things. And where necessary, I also can override those grouping by hand. So there's no funny businesses when I try to deploy some certain changes that potentially involves the moving resolver from one stack to another. Which brings me to CI CD. Since the whole code base was in GitLab already, I decided to just use GitLab Ci CD. And one technique I've used in most of my projects is to install the server framework as a dev dependency. Which means I don't have extra dependencies on the CI server, and I can just add the helper script to my package.json so that when it comes to deploying from CI, it's literally a 2-step thing to run npm CI, and that restores to the exact version of my dependencies as they were in the package.json, and then run npm run serverless deploy to trigger deployment using the version of the serverless framework that's already installed in the project. And then when it comes to testing, one of the challenges with using something like AppSync is that it's a black box. So how do you test it locally? There are tools that does simulate the AppSync locally, but I generally don't bother with them because they don't cover everything, including IAM policies. And honestly, those retail templates are really so simple. They just work. Where things tend to go wrong is in my Lambda functions, where I tend to do more complex stuff. So for those, I like to test my integration with other services like Algolia or DynamoDB by executing the function locally, but talking to the real DynamoDB table or Algolia index. I don't tend to use mocks or stubs for this or simulate them locally with things like local stack. I find them to take too long to set up and to get them work properly, and they're also very brittle and breaks easily. And also just easier to provision the tables and then use them in my integration tests, at least for the happy path. For the failure paths, where I want to say test how my code handles the DynamoDB throttle exception, for example, then I'll use mocks for those. And then for end-to-end tests, I've also got end-to-end test that runs the user story, like someone creates a profile, does a search to find activities he can join, and then send a request to join another user's activity, and then the other user logs in and approve the request and so on. And I'll run this user story test against the deploy the GraphQL endpoint. So this is always going to be run after the deployment to, say, the dev environment. And if you've got any failed end-to-end test, then great. Use this as a rehearsal for how do you debug real problems in production. If it's difficult, then guess what's going to happen when you go live? when you do have a problem in the in the live system, what you're going to do. So use this as a signal that you need to improve your logging, how you're monitoring the system, whether or not that means enabling X-ray tracing, enabling more detailed logging for your resolvers. So if you're struggling to debug problems in a controlled environment like your end-to-end test, then you're going to have a much bigger problem when it comes to dealing with problems in the wild. So don't optimize for your comfort with local simulators. It's going to give you a full sense of security. And finally, let's talk about the AWS organizations, how I set it up. So as I mentioned, I have several org units and AWS accounts that falls into them. I don't want to manage any of this by hand. And I want to have infrastructure as code for all of this as well. So there's this tool called Org Formation, which gives me exactly that. It's an open source tool. It lets me provision and manage my entire AWS organization with infrastructure as code using a YAML syntax that's very similar to CloudFormation. And it also makes it really easy for me to sort of model and template my landing zones as well, which is something that you may be able to do with Control Tower. But the problem with Control Tower and its account factory is that it's great at spitting out new accounts based on your template, but when you update your template, it's difficult, or you can't go back and update existing accounts. With this, I can, because I'm templating my CloudFormation, and then it's able to then deploy to different organization units or accounts based on how I configure things. So basically, all my infrastructure is going to be provisioned to a new account. It's going to be templated in this tool, things like KMS encryption keys, VPCs, and so on. So in this case, I'm able to declare a master account, AWS account, as the root of my organization. Again, all inside a code using a syntax that's very similar to CloudFormation, hence the name Org Formation, as in organization formation. And I'm able to provision new accounts programmatically by just, using this syntax again, and I can set up budget alarms with just a couple of lines of code. I can attach this account to my org units, which I can create in code again, and I can configure my service control policies. For example, here, I'm saying that because I know I'm only going to be using EUS 1, so I set up a service control policy that denies all actions against regions other than EUS 1, apart from those global services, of course, and then apply this policy to the root of my organization. So it's applied to all the accounts. And I can also set up a password policy for AWS users, so everyone have the same policy in all my accounts. And whenever I make any changes, I just have to run one command to update my entire AWS organization. And then to configure my landing zone, I can configure what is called a task, where I can specify a CloudFormation template. And I provide a binding to my organization, which basically says which resource from the template should be created in which AWS account. By binding its resources to organization units or to specific accounts, or accounts that's got tags or a bunch of different filters. So this is taking the ideas from aspect-oriented programming and applying into how you model and structure your organization landing zones. So here's an example of one of these templates where I've just got a normal CloudFormation resource for an IAM user, and I bind this resource to a subset of my accounts in the organization using this organization banding, which allows me to filter by, in this case, to a specific account or a specific set of accounts. And then down below, I can iterate through other AWS accounts that are provided by this binding to say, don't worry about the syntax or the mechanics of it. Is basically, we are iterating through a number of accounts that's been matched by the binding, and then we are constructing this IAM policy using this particular syntax, which the org formation gives you. So to update my landing zone for all my accounts, again, just one command and kaboom. It's really, really powerful tool. So I do recommend you go and check it out. It's available from GitHub and is maintained by someone from MoneyU, which is a bank here in the Netherlands. You can also join the Slack group to get help as well. I know the guys from Steady has recently onboarded with this tool, and they're finding some really good success with the tool as well. So that's kind of the three main tools I've used in this project: the Serverless framework for deployment and automation, AppSync for managed GraphQL, and Automation for automation around the entire AWS organization and my landing zones. And if you go back to the goals I started out with in terms of speed, getting everything done within 4 weeks for the first version at least. Since then, we added a lot more features because universities love what we did, and they asked us to support booking classes from university sports centers and things like that. And you consider the amount of stuff that was involved, and I was working part-time on this the whole time. So speed of development, definitely a check there. AppSync supports can easily scale to millions of users, so scalability check. 0 EC2 instances, no servers to manage, no networking, no VPCs, none of that. So minimum upkeep, the whole thing just runs itself. Check there. As for cost efficiency, so we've been live for about a month now, have over 10,000 organic installs and averaging around 150 to 200,000 API requests per day. And that's going to grow as we add more users. And our AWS bill last month was just under $60. Most of that is on the AppSync caching. Considering that we're only using about 5% of the cache capacity, that's about that sort of $31.68 is going to stay pretty flat even as we grow our traffic by 10x. And it's going to save us tons of money on the Lambda and DB cost. And besides what you see here, there's also another like $15 worth of cost on CloudWatch logs and the X-ray. We signed up to the AWS Accelerate program for startups, so we got plenty of money left in the credit to keep us running for 2 years. All in all, it's a pretty reasonable price to pay for something like this. And in terms of the actual latency, in general, it's pretty good as well. P99 is stable around 500 milliseconds during the day when people actually use it. But when it's the middle of the night here in the Belgium, where the app is actually being used, you can see those P99s are going up a little bit because there's more Lambda co-starts and other things like that. But overall, we're still quite happy with what we see in terms of the performance and in terms of the cost as well. So that kind of brings me to the end of this talk. So thank you guys so much for being with us, especially the guys that are in Europe. I know it's pretty late here. As I mentioned earlier, I spend most of my time as an independent consultant. So if you want to see how serverless can help your company go faster, or you need some help scaling up your team, then let me know. Go to theburningmonk.com to see how we can work together. And I've got a new video course on AppSync, which should be opening up for early access pretty soon. Should be the next couple of weeks. And I'm going to give away one copy tonight. Of course, there's nothing to give you yet, but we remember you. So when we open up, you get a copy for early access. So yeah, again, thank you guys so much for sitting through the whole talk. And yeah, let me know if you've got any questions for me.
Thank you. That was amazing. My my head is still spinning, trying to catch up. Open it up to questions from anybody.
Can I ask one?
Yeah, sure. Hey, Rahul.
Yeah. How's it going on, Jan?
How's it going, man? It's pretty late where you are.
Yeah, it's been right now around 4 a.m. in India.
Oh my God.
So, but I have really question about what does caching really means? And the second question is really my, initial question about that custom group, which I'm really dealing with about couple of weeks, and also really asked some of the members in breakout session. So what you discuss about that custom role creation in the Cognito, is it really static? Static in the sense, do I need to constantly add manually each and every time that you just told that we need to kind of send an invite to the universities and then they will accept it? So instead of really doing that, my project is really similar but does it differently. So what I really want to do is exactly, users really add a college name, their name and basic details, and a custom, I really want to dynamically create the user groups. So is it really feasible to do with Cognito, or is that, we have to specify a custom JWTs and authorization with, let's say, DynamoDB?
Yeah, so the first question, I guess around the caching. Caching just means that the API gateway, AppSync receives a request, and for one of the resolvers, for example, it says, "Oh, Yen, you're interested in the basketball. Let's fetch from DynamoDB the full record for basketball, including the display name, the image URL, and things like that." Well, instead of going to DynamoDB, AppSync is going to check, do I have it cached already from somebody else who's already asked for basketball? If so, I'm going to return it. And the nice thing with AppSync is that they added support for you to control the control what goes into the cache key. So I can say either use the whole request as a cache key so that the response is cached for individual users. So you and I is going to get different results because we're going to get different.
Does cache as a null request?
Sorry?
Does cache counts as a null request? I mean, if I'm really taking
No
something
request.
from cache, null means zero request. If I'm not throwing any request to the, let's say by AppSync or to the API gateway, I'm not essentially charging that. So is the caching really means that I'm really saving a cost by paying a little bit extra?
You call out the request to DynamoDB, but not the AppSync request itself. Okay. And the same applies to API gateway. You still get charged for the API gateway request. It just doesn't go to the backend from whatever API gateway is connected to. So if you want to call out that cost altogether, then for API gateway, you put CloudFront in front of it. So you cache at the CloudFront level, so the request doesn't even go to API gateway. For AppSync, you can't really do that, unfortunately, because with GraphQL, you got one endpoint that everything flows through. So you can't just cache that one thing because, well, that's every single request getting the same cache response back. So it wouldn't work. But what you could do with AppSync is just to say, you know what, we can cache the whole request, but because everyone's going to make the same request, but maybe asking for different data. So it's much more efficient to be caching for specific things inside that request. For example, individual sports, individual users, so that I can cut out most of the requests going to DynamoDB, which is why I got like 99% the cache hit rate, because most of the data is just nicely cached at the nested resolver level. Second question around the Cognito groups. So the groups themselves, they can be dynamically generated by API call to Cognito. However, you need to integrate them into your GraphQL schema, and you can't really do that easily, at least programmatically, not in a way that's going to be safe to do, I think. And also from what you described, it sounds like you don't need to have a separate group. You need to have a group that identify different type of users, but for different users that's associated with different entities, you can just stick a custom attribute on the user, and that's what we've done here. So all university admins belong to the same group, but each user, each admin has got a different custom attribute that tells us what's the university that they are the admin for, which means when they ask for a request to say, get my university, we can take the custom attribute for the university ID and then use that in the request to DynamoDB. So we never have to take the actual university ID in the request itself.
So is it really means it's a game of like permissions and at the database level?
Not at the database level, but at the GraphQL schema level.
Okay, yeah.
Hey, just a quick follow-up on the cache. So I get the cache hit and miss if it's either exists or doesn't. How do you handle recency? Is there just a time to live, or is it like how, the consistency issue?
Yeah, just a TTL. So with the AppSync cache, you can configure different TTL for each resolver. So for stuff like the sports, they literally never change. Like the founders, once they configure them, that's it. Maybe occasionally they want to change different image or something like that, but I can stick a really long cache TTL on that. For other things, like for example, when I see you in the app, well, do I really care if I see the latest picture you've got on your profile or the stuff like that? Probably not. But I do want to, basically allow everyone to see, your profile and not have to go to the database every single time. So I maybe put like a 10-minute cache TTL for that resolver. For other things, for like search results and things like that, those we may not even put caching at all, or very short caching, because new people is going to post, going to join the platform, or they're going to post the new activities and things like that. So it's really quite flexible with how you can how you can control the caching.
I have a question along the line of caching. Would it be even beneficial to use Dynamo tags in conjunction with AppSync cache, or is there any use case that you would use that?
Probably not. Well, with DAX, you have to pay another thing that's got a caching for what. Basically, with DAX, you also have to pay for uptime for memcached node, but that's going to be managed by DynamoDB instead of AppSync. And really, I don't think the fact that you cut out most of the requests of DynamoDB already, I don't think it really justifies adding something like that to DynamoDB. But I have seen people use the DAX, not with AppSync, but with other APIs where maybe they can't really cache at the API level. For some reason, maybe they're just the cache keys or the query string parameter just doesn't quite line up perfectly, but they can put a caching in the DAG in the DynamoDB layer instead. But for this, no, I don't think it would. I don't think it would make sense.
All right, thank you.
So I had a question regarding DynamoDB versus like other NoSQL databases, right?
Versus what's the second part? DynamoDB versus something else?
Versus like versus like other NoSQL databases or other databases such as Neptune, AWS Neptune. So what can you tell me why you guys decided to go for DynamoDB versus like some other type of database like Neptunes? Because Neptunes is a database that it's very native for like social media, and it's got a couple of use cases on some social media's app that have used it. So I was just wondering
Sure.
the reason.
So Neptune is a graph database. So the way you query things are very different. It's great for doing graph traversals, the kind of problems you solve, like find me friends, find me people who are friends of, say, of Ken, and also likes Battlestar Galactica. So those are kind of things you can really easily find, or find the second degree followers or followees and things like that. That's the sort of problem that graph databases are great for. And I love the use. I love the Neo4j, which is another graph database, which was still the most popular one. However, for most of what we do here, we don't actually need it, because most of what we do is key lookup. And also there's no direct integration between the AppSync and the Neptune. So if you want to do something like that, you have to go to Lambda. That said, as for us, so for our social network, there's really not much, I guess, connections. So there's no, and I can't follow people. I can join the activities, but I can't really follow them as such. For one of the other social networks that worked for in the past, that we did use the Neo4j as a graph database. However, you also need to keep in mind that the kind of problems that graph databases run into is a problem of complexity. So the whole graph issue is that everything is connected, right? So if you scale to have millions or maybe even tens of millions of users or connections, you're gonna be jumping between servers. You can't fit everything on one server anymore, which means when you're traversing the graph, you're gonna keep jumping between different servers, and thus they have to put a limit on how many hops you can do, or they put a limit on how big your graph can grow. So Neo4j have to force you to run everything on one box. So essentially, as big as say your memory can hold for your graph, and that's kind of your limit. But Neo4j lets you run arbitrarily complex queries against your graph. Something like Neptune is different. Neptune, I think, actually I need to double confirm whether or not it supports horizontal scalability, so that your graph can actually span across multiple nodes. And with all the different social networks, they don't actually use a graph database. None of them do. Partly because of this issue of, okay, once it gets big enough, you just can't do it anymore on a graph database itself. So what everyone does is that they do everything in a batch. So for example, LinkedIn, Facebook, everybody, Facebook in fact has got this whole, I forgot what it's called now. It's got a silly name like Dragon or something.
Does uses like the graph database in mutual
It
friend
doesn't use
suggestion?
graph database. They run graph queries against the Hadoop. So they have got this whole framework that runs on top of Hadoop. And that's like a name for it. I forgot. I think that's Dragon or something silly like that. But yeah, so everybody at certain level at scale, you just can't use a graph database per se, but they run some kind of a MapReduce over and run graph queries on top of some kind of MapReduce thing. And most of the things that you see in the LinkedIn and the recommendations, things like that, those are done in a batch. They're not live. They are not served live. But yeah, graph database really cool. But for our case, we just don't have a need for it. At some point, we might do. So for the other social network I worked at, what we have is we got DynamDB for the key value lookups, but we also sync the data to Neo4j. So when it comes to doing specific queries like finding second-degree connections to do recommendations and things like that, we use the Neo4j for that. We don't have the use case for this social network yet.
All right, thank you.
Okay, no
Yeah, and I've got a question. I was intrigued by the hoops you had to and were able to jump through with CloudFormation limits. And I'm wondering. I know you have an article on using SAM with Terraform. I wonder if Terraform might have alleviated some of those issues.
It might, but you will create a lot of other problems. Mainly, okay, how do I configure all of my AppSync resolvers easily? I've got 200 of these guys, which is going to be without a nice abstraction layer to work from, it's going to be pretty painful to deal with. And the same with API Gateway, Terraform. Now, if you write the same API in the serverless framework, there'll be 3 lines of code. In the Terraform, will be maybe 200 lines of code. So in terms of abstraction layer, I think Terraform for a lot of cases is just not productive enough. That said, if someone comes up with nice modules, maybe that will help. I'm not sure. Need to see.
Okay, but it is that plugin you found that would automatically break things into nested groups. Oh my God, I wish I knew about that 3 years ago.
Yeah, I mean, AWS has been kind of hinting, at least Chris Munns hinted a while back that something is coming to CloudFormation to maybe alleviate this 200 resources limit, because it's kind of arbitrary. Because really the limit is 200 times 200. If you stick 200 nested stacks in there, that's 40,000 resources. Why not just allow 40,000 resources in one stack? So let's see what happens. It's one of those things that I just keep bumping into all the time. So this plugin has been really useful for me.
Okay. I mean, the one thing I'll just say is that with the nested stacks, change sets still aren't all that useful. So anyway, okay. Why don't we do the raffle, because this is when we tend to start having people fall off a bit. So Jan, do you have a trivia question you'd like to ask people? And and I'll just say before you do, and what we'll do is the first person who answers in the chat wins. But
yeah, I don't. Please ask some Battlestar Galactica.
All right, Ken and Jen.
Maybe I'll ask one. I'll ask one. So what's the name of the spin-off show for Battlestar Galactica?
Someone said Battle Planet Galactica. No.
That's the next question if we need another.
We will. Well, I know the answer, but I'm not gonna say.
And Brian, which thing are we raffling here? Is this for the AppSync course?
Yes.
Okay.
Oh, well, geez, I want that, and I do know the answer, but I'll be a good host and not.
I think we're excluded.
Oh, come on. No one, you've had time, people have had time to Google.
You can Google, yeah.
Can the question be changed?
Okay, someone said the Caprica.
Oh, yeah. They misspelled it, but okay, sure.
Good enough.
Jacob got it's Battlestar. It's well,
Africa.
yeah. Now the funny thing is that you said Battlestar Caprice, which is actually my wife's name. I mean, not Battlestar, but her name is Caprice.
Well, sometimes.
Yeah.
Check might have corrected it as I was typing it.
So Jacob, if you can private message Jan and you guys work out together, but that's really funny. Yes, my wife's name is Battlestar Galactica Caprice. Okay, so we have two gift cards, and Jen, you have a trivia question?
I do. There is a very famous conference that went virtual, like all the other conferences, that kicked off today, and it is in New York City. Name that conference.
Battlestar Galacticon?
No, not too far off.
So what type of conference?
Something that I would go to for sure.
Not Comic-Con?
Who said that?
I did.
You got it.
Am I allowed to win the raffle? I don't know.
Ryan, what are the rules? That was my question.
Sure. Let's give it to Jan. I'm sure you don't have any AWS credits as a hero.
Yeah. Wink.
Okay. All right. Ken, come up with a question, but I'll ask one more. So what's the one actor who played in both the original Battlestar and in the reboot? And I'll take either the actor's name or the character's name. Come on, we're geeks. We should know. Yes. A. Richard Hatch, who was Apollo in the original series and Tom Zarek in the spinoff. So A, if you write to me, Brian Tarbox at gmail.com, I'll send you the link. And we need one more trivia question.
I'll give a AWS-centric question to balance it out. This might be too easy, but so get ready to type fast. What AWS service was in preview for 22 months and was just become GA last week?
Jan, don't answer that.
Nope, not AppSync. Not EKS. No, the console redesign they just came up with and started in 1 week. Time stream, there it is.
Okay.
So Brian, yeah. So Brian, send Brian Tarbox your information, and he'll send you the code. Congratulations, everyone.
Yep. That's good. Thank you.
Say, yep.
Yeah, I
So-
have a quick question for you.
So can I answer Thomas's question? Why Algolia versus Amazon AWS
Thanks.
Cloud Search? Do we have time for that?
Sure. We have all the time. It's up to you, man.
Yeah. So
You're the one, Slate.
so Cloud Search is kind of a bit of a deprecated service, not officially deprecated, but almost nobody uses it anymore. With a Cloud Search, I actually used it in a previous project many years ago. It's got a lot of basic things you need. However, if you ever need to scale from one node to another, it's going to be a half an hour wait. We actually run into problems with that in the past. Whereas with Algolia, it's really kind of serverless in the sense that you don't have to worry about provisioning servers and scaling up the node size and the number of nodes and things like that. You just use it as a service, and you get charged for how much requests you make, so it's much more sort of serverless in the way that it's just a managed service that we can easily consume via an API without having to worry about EC2 instance size and things like that.
So maybe a more fair comparison would be to Elasticsearch service.
Yeah.
You wanna comment
So
on that?
similar thing with Elasticsearch, you have to use set up VPC, set up security groups and subnets and all of that jazz, and then you have to worry about sizing the nodes and things like that, which I actually did for another project recently for US client, because Algolia, if you want the it's a HIPAA project. So if you want the HIPAA compliance with Algolia, they told us $75,000 a year, and we're like, no thanks. And so I spent like 4 days setting up VPCs, networking, all of that, and get the Elasticsearch running. But four days, that's a long time for me to actually work on one thing. And so yeah, if as much as possible, I like to avoid Elasticsearch, just because how much plumbing I got to do around it.
Yeah, it's interesting that DynamoDB docs actually recommend using Cloud Search, and I've not found anybody you kind of to handle more complex access patterns, specifically kind of search oriented. So yeah, it's interesting that JamStatConf was pushing Algolia pretty hard over the last couple of days. So that's an interesting secondary recommendation for that. Thanks for sharing that.
Yeah, Algolia is a really nice service to work with. They've just changed the pricing model, so it might be a bit pricey compared to what it was like a month ago. But yeah, it's a very nice service, and there's a free tier as well, which is probably enough for like a personal project and things like that.
Thanks again.
Cool, no worries.
Any other questions? Well, great. I'd say thanks again. This may have been the most geographically diverse set of attendees we've had in a while. Thank you so much. Everyone, come on back in 2 weeks for a talk on CloudFormation compared with Terraform. And everybody, stay safe.
Thanks everyone for joining.
Thanks everyone. Take it easy. Bye bye.
Thanks, Jan. That was a fantastic talk.
Thank you.
Appreciate it.
Yeah, thank you.
Bye bye.
Thank you. Bye.
Nice job, Ryan. Thanks.
Oh, no, thank you. And I'll start processing the recording and I'll post it to you as soon as it's done.
Fantastic.
All right, cool.
Have a good
Cheers.
night. Bye-bye.